Well, hello everyone out there in the virtual world. Welcome to Stormwater Data Using Technology to Inform Program Decisions. My name is Tom Petroni. I'm a Senior Technical Director at AKRF, and I'm here today to talk to you about everyone's favorite insane asylum called Twitter, and how we go about unlocking Twitter and high-resolution radar rainfall data to better understand urban flooding patterns and extents. I have a lot to talk about. I only got 20 minutes, so let's get right to it. The presentation, quick presentation overview, get you a little oriented. First, we're going to talk about some background and history and why I went about doing what I did, why I went into this rabbit hole. We'll talk about how to harness Twitter for flooding data. We'll get into some GIS mapping. Yeah, I love myself a good map. Always love a good map. So we'll talk about that. And then, some of this high-resolution radar rainfall data and some key takeaways. So first up, just background and history. So this study is for the Pittsburgh region, which is Allegheny County, and in 2018, actually had the wettest year on record, like many other places across the East Coast as well. The city of Pittsburgh on average has about 35, 37, 36 inches of rainfall on average on a year. This year we had places in the county that were upwards of 70. So, over this year, we also had, over 30 calendar days of extreme localized flooding events that occurred. It seemed just like every day there was a new urban flooding challenge for our county, and we had 3 state of emergency declarations, and actually we had one fatality as well, which was very very sad. But when all this was occurring, I said to myself, we need to be documenting this. We need to be not just moving on. So many times when we have these flooding events, we just decide, let's keep moving on and not actually go back and document what happened. So I said to myself, I'm going to create a story map of this and not let that happen. I'm not going to let this just fall back into into people forget about this and move on. So I made this story map, and it was a big hit. It actually had thousands of views, and I created video. There was videos I linked to and images. I also included interactive rainfall maps that allowed people to click on rainfall and see actually how the rainfall impacted places during certain events throughout the year. So this actually was a great way of just documenting and taking that data and putting it into a place where people can actually view it and not just move on. And during the time of this 2018 rain season, 2 reports actually came out that were quite timely as well. And the first was this growing threat of urban flooding, a national challenge, which was in 2018. And the second was this urban flooding moving towards resilience report. And both of these reports talk about this challenge of the lack of data and lack of documentation. And we don't have data at our disposal that's easily interpreted or spatially identifiable format. We need better data to understand urban flooding, where and why this is taking place. Detailed data and strong visualizations can help. And I totally agree, and that's why I did what I did with the story map, and that's really how this presentation is the backdrop of this entire presentation I'm giving today. Is this issue of we don't understand this issue of urban flooding as well as we should, and we need to start documenting this. So when it comes to data, these are some quotes that I totally agree with. Maya Angelou, if you don't know where you've come from, you don't know where you're going. How do you know where you're going if you don't know where you've been? That's so true in my opinion. Winston Churchill, really the master of quotes a lot of times during his life. But I love the one where the farther back you can look, the farther forward you're likely to see. Isaiah Berlin, to understand is to perceive patterns. And finally, Alan Mulally, the former CEO of Ford, reportedly began every meeting with, "The data will set you free." And I'm here to agree with that and maybe set urban flooding free with data. So this urban flooding data, when I was doing this 2018 story map, I was on Twitter a lot, looking at a lot of the reports, and I noticed Allegheny County was just on top of so much flooding that was happening across the Pittsburgh region. Their Allegheny Twitter feed, I'm like, man, this is really a treasure trove of great flooding information all across. And it wasn't just 2018; they were doing this every year. 2019, going all the way back to 2012. So I was thinking to myself, I was scratching my head like I am now. I was like, how could there be a way I could automate the extraction of all these flooding tweets and map them in GIS? So of course that answer is yes. Otherwise I wouldn't be giving this presentation today. But I'm going to show you how I went about doing that. So Twitter has a API, which is a application programming interface, and if you don't know what an application programming interface is, and you're an engineer out there, or you should really learn what this is soon, because this is the way to get data off the internet easily and analyze it. Twitter's API has a lot of rules and nuances to it, and they want to get paid for it. So there's a lot of, I'm going to get into those nuances as part of this presentation, but API is something you should definitely start looking into if you're looking to do something similar along the study. What I did though was a method called Twitter scraping, and what Twitter scraping is basically just a brute force method of getting data off Twitter. And what Twitter scraping is, you're basically just going to each and every page and using an automated approach to Python. So I went to Allegheny County's Twitter page, and I manually scraped 17, or not manually, but I did it in Python, over 17,000 of their tweets. And this is a quick video of Python doing its thing, going through each and every single day of Allegheny County's Twitter feed and scraping all the text off of their page. And then when you take that text, it automatically puts it into easily workable format, which is like a CSV file or text file. And once it's in a CSV file, you can do some pretty cool things with it, especially if you're already in Python. So I took those tweets, I filtered them by the text flood, and I was able to identify 535 different tweets pertaining to urban flooding reports through that data extraction. So this is a quick plot of that data plotting and analysis. This is the number of flood tweets on a given day for the period from 2012 to late 2019. And this is just showing, how often, just giving a rough sense of how and when Allegheny County is tweeting about flooding in the Pittsburgh region. And you can quickly see from this that you hit these dead periods in the winter, and in the summer, you get 20 tweets, 30 tweets in a day. Sometimes over 10, 20 tweets in a day. Some of these high points are. So I also went and, what is it by month? Because it appears that the month is a big driver here. And that's certainly the case. What you're seeing here is, so this is the number of flood tweets on a given month for throughout that whole period. And certainly, you're seeing 20 tweets, 10, 20 tweets, 40 tweets there in 2018 in June. And in July 2012, they had up over 120 tweets related to urban flooding reports. Finally, the number of tweets, right, that's fine and all well and good and all, but I'm probably we care more about the number of days that they tweeted, right? How many individual days did Allegheny County tweet about flooding? And that's what I'm showing with this map. So, 2013, that same 120 tweets, there was 6 days. Those all fell within 6 days. So that's what this is essentially showing is, 3 days, 4 days, 6, 7 days of tweets, 7, 8 days of tweets where in a given month where Allegheny County is tweeting about flooding. And finally, just confirming, just those plots, that May, June, July, August, September in the Pittsburgh region, according to, from analyzing these tweets for 7 years worth of data, is the flooding season, and that's really what these tweets are showing. Is, you know, you're seeing these summertime cloudbursts, thunderstorms are impacting flooding in the Pittsburgh region. You know, one thing that's great about these plots, they're all made in Python. They're all, once you have it in CSV, like I did earlier, making these, I've been a total and complete convert out of Excel into Python. I've become a quite a Python enthusiast, and I've changed my mindset on getting out of Excel as much as I can. So another great thing for Python is GIS mapping, and so each tweet, as I was looking at these tweets, you know, they all contained useful GIS location information. And I said to them, you know, typically these three, and they came in three type of locations. And the first was the street intersection. Right here is this is in Turtle Creek, you know, flooding on Railroad Street at Line Street. So that would be this is type 1. This would be a GIS point file. The second type would be, you know, a block of a street. So that would be 4,700 block of Streets Run Road. This would be a type 2. And that would be like a line file. And the third would be like a crossroad, right? So this one is a Mayview Road between Boyce Road and Willowbrook Drive. And this would be a line file all along Mayview Road between those two streets. So, you know, I all those maps, all those points and all those lines, would put them on a map. And that's what this is showing. This is 651 map locations of, and you might be asking yourself, well, why is there more map locations than tweets? And the reason that is because sometimes Allegheny County would tweet in multiple locations within a single tweet. And I would need to, you know, break those out and then map those individually. So that's kind of why there's more map locations than there are actual tweets. And interestingly enough, I also overlaid these with the FEMA flood zones, and 54% were outside the FEMA flood zone. So I think this is just kind of confirming to me, in my mind, those reports that we saw earlier, was that this urban flooding issue is widespread, right? You look at this map and it's a shotgun. You know, there's really, it's all over the map, and it appears that there's really no rhyme or reason for these reports. It's truly a growing threat. So what if you take this data and combine it with the high resolution radar data that I have available for Allegheny County? It dates back to 2005. This is ran by Three Rivers Wet Weather. These use high resolution XRAD data scans, and it's calibrated at 33 local rain gauge. This is really good data information on 15-minute time resolution. So all these tweets have a date timestamp, right? So they using these date timestamps, can we do a flooding forensics, if you will, of the flood prone areas? Can we understand the rain events that are causing this problem? So I took a watershed, Sawmill Run watershed. For those of you that might be familiar with the Pittsburgh region will know that this has been a problem area for Pittsburgh. As shown in these pictures here on the right, this has been a continual area of flooding danger and threat to the region. And so I examined these flooding tweets, and I examined the dates and the rainfall. So here, in total, there were 17 between 2012 and 2019, 17 flooding reports somewhere within the watershed. And to the map to the right, this is also made in Python. This is a GIS map of an animation of the rain event that occurred on June 14, 2017, that created catastrophic damage in the watershed. And what I did was I took all these tweets, and I took the start of the rain on that day and the end of the rain on that day of that tweet, and I extracted that rainfall data for the watershed. And for each of those flooding events, I then took the total rainfall of the centroid of that within that watershed, and I said, hey, let's run some rainfall statistics on these rain events. Let's see what they look like. Let's start breaking down some of the statistics of these rain events. And this is a quick table of what those rain events look like. You know, this normally you like to see the total rain event, right? How much rainfall event fell during those 17 rain events. The max 15-minute rainfall, what was the intensity, the 30-minute and the 1 hour rainfall total rainfalls. So, you know, looking at these rain events, you see that, you know, roughly around 2 inches per rain event on average is what we're seeing out of these rainstorms. And then for the 15-minute, you know, you're seeing roughly around ½ inch for this cloudburst, ½ inch to a 0.6 rainfall in 15-minute time frame. Same goes for the 30-minute, where you're seeing, you know, roughly 1 inch, and for the hour a little bit more than that. So what you're seeing in my mind when I look at this data is most of the rainfall is falling within an hour time frame, or less than even less than an hour. 30 minutes. So for the total 2 inches, most of it is falling in a short time frame, which is indicating these cloudburst rain events that a lot of people are dealing with all across the country as well, not just Pittsburgh. For those of you who are curious, I also did the return intervals of these. I know, you know, these return intervals are you know, to me, I like to see the total rainfall. That helps me understand what it is as a designer, how to go about designing a potential solution. But these return intervals are also helpful in my mind for educating potentially the public on, you know, the magnitude of that rain event, or potential magnitude of how big it could be. You know, the thing with these return intervals is they're really all over the map. Some are low, some are really high, like that June 14th animation that we showed earlier. This was a massive event that occurred. But you know, this data, you know, return intervals are nice and all, but, you know, to me, let's use the real rainfall inches that caused the problem. You know, sometimes a return interval could be helpful for maybe identifying, you know, O&M issues, or where O&M issues might have caused the flooding problem. But overall, I like using the total rainfall more. So I looked at the temporal distribution of these rain events as well. You know, these are each of the individual rain events plotted, and how over time, and the fraction of rain event that occurred within that rain event over that day. And what you'll see from these rain events is, you know, most are afternoon heat convection storm events. You know, most of these occur in the afternoon hours. Here's this dark green line is the June 14th event. So that occurred, you know, roughly before 6 p.m. And, you know, I then center shifted and created an average distribution of this rainfall. So me as an engineer or a planner or designer, you know, we often use SCS curves or NRCS distributions, but I also like looking at these actual rain event distributions. That way we can understand and model the actual rain events that caused the flooding in the first place. So, you know, if I were to design something in whether it's in SWIM or in HEC-RAS or some sort of modeling approach, I would also consider using this type of rainfall distribution to do that analysis. So some key takeaways here in the last minute and a half. Urban flooding is to me, it's the greatest challenge facing water professionals. And I'm sorry if you're different, if you're in a different water profession. I believe this is true. And no, but, you know, all due respect, I think this one, you know, it's widespread, it's isolated, you know, it's unpredictable, often dangerous, costs lives, and it's costly, and it's not only, it's getting worse. This issue is not getting any better with climate change bearing down upon us. And secondly, we should be using more real data observations to better inform our and plan our future strategies. I truly believe that we need to be documenting and tracking these urban flooding when it occurs, just how I've shown on that previous database that I compiled using Twitter data. We should be doing this for every city. We should be tracking and plotting and GIS mapping all these flooding events along with the dates and whatever information we can compile. And we should be sharing that. We should be sharing that with our designers and our engineers and planners. We should also be harnessing social media. You know, so say what you will about Twitter and the things that go on there, but there's a lot. To me, there's a lot of useful information out there that could be used to unlock this challenge. We should be encouraging more citizens to report and document and help out. And everyone has a cell phone in their pocket, right? We could be all contributing to understanding this issue better, in my opinion. And we are really in the age of automation and large data sets. This is no longer the future. This is now. Taking this data and processing it and making sense of it has become the standard quo in my mind. This is what we should be doing. And it's not a lack of data. It's becoming less and less of an excuse in my mind. If anything, we have too much data a lot of times. We need to scrape it out and get to the good stuff. That's the issue that we see more now, if anything. And my mind, more engineers and planners should be considering these types of approaches, these innovative approaches, social media data sets, working with crowdsourcing, those types of issues, especially when it comes to urban flooding. So I only talked about really two key takeaways: regional watershed planning, and there's all these other approaches that you could do with this data. Hydraulic model verification, H&H studies. I think all this data could be used: social and economic impacts on flooding analysis. And finally, that's it. I'm all done. I run a blog, and my contact information is on the right. My blog, it's gotten a lot of traction. I actually wrote an article about this Twitter thing called Twitter, not just for lunatics, also useful for flooding information. So if you want to check that out, please head over to the blog and read all about this. I have a lot of fun with it, as you can see by that title. But yeah, I'll look forward to meeting everyone, hopefully during the Q&A. All right, see you.